This graph, where we start at the point where x is -2 and y is 0, and we have a direction moving up across this parabola and then back down, one version of that would be the vector valued function r of t equals t times I plus 4 minus t squared times j. Of course, you could go back if you said this was x equals t, and then this would be 4 minus x squared, so y equals 4 minus x squared. That would show you that it's this particular parabola, but the vector value function gives us a direction, just like parametric equations would give us a direction. Only it's just a little bit differently. But just as in parametric equations, you can use a different parameter. Instead of using t, we could use t squared minus 2 and change our change our limits for the curve into between 0 and square root of 2. And if you can see that, I hope you can see that these two curves would be the same. Just the point would be moving along there at a different tempo. But the graph of this one, see, if we put in 0, we get no, actually would be different, because we get -2i. No, that is it, right? -2i, that's here. And if we put in 0, this would be 4 minus 4, so 0, so that would be fine. And then it will wind up at, when we put in square root of 2, square root of 2 squared minus 2 is 0, so x would be 0. And then putting in square root of 2 here, we get 0 here, so 4. And you know what? I do want to see the whole graph. I want it to go all the way out to here, so I guess I would say, whoops, I didn't mean to say square root of 2. I meant to say 2. Because if we go to 2, then this is 4 squared minus 2, which is 2. And this curve describes the exact same graph. But they wouldn't be traversed in the same fashion. Because one would actually move at a little bit different. X would move at like a quadratic speed, and x for this one would be moving at a linear speed, if that makes a little bit of sense. Quadratic means it'll get bigger, faster. This one is just changing, x is changing in linear fashion. So one, since x is changing in linear, would kind of be like this, and the quadratic one would start out slow and then speed up and get real fast at the end. But anyway, that's two vector valued functions describing the same curve, but the vector is moving quicker to some extent with this one.